US Physics Olympiad, year 2022. F equal MA, first round. Exam B. This year Olympiad was split by two exams, A and B, and all students could participate in any of these exams. As usual, it was given 75 minutes for 25 problems. Please subscribe for this channel if you want to get more interesting problems. Problem number 1. A ball is held a height h above a slope, which is at an angle 45 degrees from the horizontal. The ball is dropped from rest. Assume the ball bounces off the slope perfectly elastically. What is the distance between its first and second impact points? Problem number 2. A massless wheel of radius r has 4 small masses m placed evenly along its rim. Let the moment of inertia for rotations about the center of wheel and the plane of the wheel be I0. Now consider rotations about the two axes shown, with the corresponding moments of inertia I1 and I2. Which of the following is true? Problem number 3. 4 evenly spaced points are marked on a massless seesaw as shown. 2 blocks of masses 5 kg and 7 kg are placed on the seesaw so that it balances when the fulcrum is at point 4. The diagram is not drawn to scale. Now suppose the fulcrum is moved to point 2. How much mass should be placed at point 1 so that the seesaw again balances? Problem number 4. A firework explodes, sending shells in all directions in a vertical plane as shown. Suppose the shells are all launched with the same speed and ignore air resistance but not gravity. A long time later, but before any of the shells hit the ground, what shape do the shells make? Problem number 5. A swimmer swims at the speed v relative to still water. A river flows from a pier to a lake with the speed u. If the swimmer swims downstream from the pier to the lake, then back upstream, what was the average speed during the trip? Problem number 6. A block of mass m is at rest on a frictionless table. It is pushed horizontally by a constant force F and has a total momentum P when it reaches the end of the table. If a block of mass 2m is pushed across the table in the same way, also starting from rest, what is its momentum when it reaches the end of the table? Problem number 7. 2 blocks of unequal masses big M and small m are hung from the ends of a massless frictionless pulley as shown. The blocks are held in place and the entire pulley is mounted on a sensitive scale. After the blocks are released from rest, but before either has fallen off the pulley, what is the scale reading? Problem number 8. A ball is launched with the speed v at an angle theta to a fixed ramp, which itself makes a 45 degrees angle with the horizontal. Assume that when the ball hits the ramp, it bounces elastically and frictionlessly. For what value of theta will the ball bounce off the ramp 2 times and then return to its original launch point. Problem number 9. Bill is leaning on a box of mass 30 kilograms, exerting a force 35 degrees below the horizontal. If the coefficient of static friction of the box on the ground is mu s equal 0.4, what is the minimum force needed for the box to slide? Задача номер 10. Problem number 10. Two springs with a spring constant 2 Newton per centimeter and 4 Newton per centimeter are connected in parallel. They are both connected in series to a spring of a constant 3 newtons per centimeter as shown. What force must be exerted at the end to extend the system by 1 centimeter from its relaxed length? Problem number 11. Water with a total mass big M is poured into a cup of a cross-sectional area A. A block of mass small m, whose density is half that of water, is tied to a thin string. The string is attached to the bottom of the cup, and the block floats in the water as shown. The atmospheric pressure is P atmosphere. What is the total pressure force that the water exerts on the bottom of the cup? Problem number 12. Two identical bricks of mass m small are attached to two frictionless pulleys by a massless string on a fixed slope of angle theta to the horizontal, as shown. Suppose that the coefficient of static friction between the lower block and the slope is mu, and all other surfaces are frictionless. What is the minimum value of mu so that the blocks can stay static? Problem number 13. A ballistic pendulum is designed as shown below. A uniform ball of mass m and radius r is attached to a massless rigid rod, so that its center is distance L from the ceiling. The ball has a small tunnel hollowed out. A small block of mass m and the speed v goes into the tunnel and collides at the center of the ball perfectly inelastically. Subsequently, to what maximum height does the block rise? Problem number 14. A cylinder of water is suspended in a space station. Under the influence of surface tension, the cylinder splits into droplets. After a short time, viscosity causes the droplets to settle into static shapes. Neglecting the effect of evaporation, compared to the original cylinder, the final set of droplets will have next one. Problem number 15. 5 astronauts are orbiting Earth in a low circular orbit. They decided to go around the planet following the same orbit but much faster. To set a new record for obtaining Earth, 4 of them thought that they could quickly increase the velocity, then use a jet engine to maintain an orbit of the same shape. In the first 4 choices below, the red arrow denotes the direction that fuel will flow out of the jet nozzle. The 5th astronaut was skeptical about such a possibility. Who is right? Problem number 16. A uniform rectangular block is in static equilibrium on an inclined plane and experiences gravity, static friction, and normal force from the plane. Though gravity acts on the entire volume of the block for the purposes of torque balance, it is equivalent to a single resulting force acting at the block's center of mass. Similarly, while the normal force acts on the entire bottom surface of the block, its torque is equivalent to a resulting force acting at a single point. Which of the following best shows this point? Problem number 17. A box of mass big M is sliding to the right with velocity v on the frictionless table. A small pack of mass m/2 slides frictionlessly inside the box. Initially, the pack is at the left wall of the block with a rightward velocity of 2v with respect to the table. After time t, the pack collides elastically with the right wall of the box. How much longer will it take until the pack hits the left wall of the box again? The following information applies to problems 18 and 19. Problem number 18. A uniform rod of length L and mass M is placed with its ends resting on two identical springs of spring constant K as shown. The rod is initially in equilibrium. If the rod is uniformly displaced downward and released from rest, what is the frequency f of its oscillation? Problem number 19. Next, the rod is brought back to equilibrium. It is slightly rotated about its center of mass, then released from rest. What is the frequency f of its oscillation? Problem number 20. A uniform hollow sphere is initially at rest on a horizontal plane. The plane begins to accelerate horizontally to the right with the acceleration a. If friction is high enough to prevent the sphere from slipping, what is its translational acceleration? Problem number 21. Amore and Bronco are given a long, thin rectangle of sheet metal. It has been machined very precisely, so they can assume it is perfectly rectangular. Using calipers, Amore measures the width of the rectangle as 1 cm with a 1% uncertainty. Using a tape measure, Bronco independently measures its length as 100 centimeters with a 0.1% uncertainty. Which of the following are closest to the relative uncertainties they should report for the area and the perimeter of the rectangle, respectively? Problem number 22. A cannon just above the surface of a spherical planet with mass m and radius r launches a particle with the speed v, where v greater than square root from gm/r and less than square root from 2gm/r. The initial velocity of the particle makes an angle theta with the vertical direction. Neglect drag. For what theta will the particle never collide with the planet? Problem number 23. A mass attached to a spring is performing simple harmonic motion with velocity v as a function of t. and acceleration a as a function of t. Which of the following could be a graph of the curve a as a function of v over a complete oscillation? Problem number 24. A ramp with a height h is moving with a fixed uniform speed v to the right. A small block of mass m is placed at the top of the ramp and is released at rest with respect to the ramp. The block slides smoothly to the bottom of the ramp and onto the floor. How much kinetic energy does it gain in this process? Neglect friction. Problem number 24. A ramp with a height h is moving with a fixed uniform speed v to the right. A small block of mass m is placed at the top of the ramp and is released at rest with respect to the ramp. The block slides smoothly to the bottom of the ramp and onto the floor. How much kinetic energy does it gain in this process? Neglect friction. Problem number 25. Two masses are initially at rest, separated by a distance r, and attract each other gravitationally. If their masses are m and 2m, then they will collide after time t. How long would they take to collide if they both had masses 2m?